is Andy Shaner, who's going to be talking about the high school program that he's been running for years now. Andy.
Feel like years, but 8 good years, I should say. Okay, so I'm gonna just get right to the point in my first slide, and that is our program for engaging high school students because at least within the education world, science education world, our program anyway. So authentic science is going to school one day and doing a lab where you know with all the creation of research problems, questions, development of theories, comprehending and interpreting. So we kind of need a place to start. Otherwise you could just debate forever how you're going to define authentic science. So one way is to start with how the next generation, these are just some that education researchers have determined affect one's attitudes towards science. The box there is a bad example. So hopefully we can get students to be more like that back there. Maybe not as dangerous, but at least being ready to try science. To increase students' perceptions of the value of science. All right, so what? So why authentic science and why positive attitudes that are promoting the understanding of the processes of science? Can do science, or I feel like I'm a scientist, at least among their own peers. So students, and this is actually something that researchers have noticed going on for about 50 years, which is kind of ironic because Apollo was 50 years ago, but we've also seen this decline in attitudes. So there's been a lot of research into trying to interest toward pursuing careers, enrollment in classes, science courses, or participation in STEM activity sciences, and actually become a researcher or become an engineer. This last part is not going to be a scientist. So that's just as important. Learning environment also affects in the classroom. That can be different and be considered a different type of environment. When students can have interactions with scientists, they're going to benefit from that. They're more likely to consider pursuing a science-related and their attitudes towards it. And also, it just helps them perceive scientists as real people. Once they actually get in there and are working with them, they don't look like doctors. It's 2 semesters or an academic year. It starts in the fall in September and ends in the spring. Annually, which basically just comes down to labor because I'm the lone monkey behind the keyboard. This research that they will do is student defined, and that's important. There are programs out there where students are doing research, but they're what are considered apprenticeship models where they are maybe a month or something over the summer, but generally helping that scientist with their research, which is fine. That's great. And that we allow them to figure out what it is they want to research, and then figure out how they're going to go through that process. This program was preceded by a very similar program under NLSI. So this is just showing we're not necessarily the total number of teams, because there are schools who could have participated in multiple years across the country of the participating schools. This is a map showing a scientist advisor, many who over the years have been part of NLSI or Survey, other teams have been involved with it. The yellow dots show where advisors, it's where they were. So yes, we had, in fact, the 2 posters we had this week from our high school teams here were from one to have a poster here. And we had a lot of cases where somebody was a judge one year, loved what they saw, and then wanted to be an advisor next year. One of the things that came up in our evaluation of the original high school program was, especially if I'm not there and can really observe what's going on. As we hashed out is, when we're asked this question, what has to stay on schedule, communicate with the advisor as needed, and the advisor plays more of the scientific advisor role, helping them get papers, reaching out to other scientists for help if they need to, and that did happen a few times, which was great, so it involved even more. They both helped the students figure out what their topic could be in the sense of what can you do in the time you have, which is like 6 or 7 months, and what do you have based on, it depends on those 2 things, time and resources. And so the advisors and teachers are really important in that aspect. And just providing positive reinforcement and encouragement to keep going at times. They're going to get frustrated or they're going to get bored with data. Moon 101 and Asteroid 101, we give them a series of readings, not research papers, but papers similar to from planetary science research discoveries or some up-and-coming asteroid research. They read through those. They have a document with questions to help guide them in their thinking as they're reading all these things to help them better understand asteroid and lunar science. Because if we're lucky, kids in high school know phases, maybe something about tides, but gee, what's the word I'm looking for? Motivated teacher to get them there through Earth-space science. So at the end, they do all those readings, and the product for this portion is they take 3 images from the lunar surface. I'll give them some feedback on the science portion, some feedback on the presentation portion itself. So the research follows these 101 presentations. In the spring, about April or May, usually in time to a PDF of it, and then we get judging at LPSC. They get a week to judge, and then judges again via Adobe Connect. They get about 7 minutes, and in which time they can address comments from the judges and anything else that may have been in it. They can redo their poster, decide who are we going to send here to present their poster in person. And what I tell the judges is, as of right now, they're considered equal. You know what their research is talking about. Could they answer your questions? Did they have to, did they know what they were doing? And that's what I asked them to consider. Reasoning, just who would you pick? And without even blinking, they all chose. I thought about wasting time just to make it feel like they really were struggling, but we got right back on and told them. So over the entire area of science, they have an after-school research program. It's usually biology-based, but the 4 this week. In that time, we've had 7 student poster competition awards, from honorable mention to one of the original teams from San Antonio was invited to present their research to the Texas State Legislature. Their research was in the fall 27 issue of ArcUser. They were using ArcGIS for their research, and in May of this year in Pittsburgh. Kickapoo in Missouri was quite well known during the original NLSI around here. Is trying to determine their origin. That paper, so they wound up, students came back from college the next spring to present an oral at LPSC, and they were featured in the December 2013 issue of Science. So we did pre and post content surveys, attitudes towards science, which I'll talk a little bit more about. So the specific survey, we had one that I used in and make sure it's also reliable. It will consistently do that and maybe even do it across different audiences. And we changed it from a traditional item, asked them to consider the same thing, but before they started. And if you want to talk about why we did that, I'll tell you later. So it's pretty reliable. You're looking for a factor analysis, and based on the responses of all students, exactly what we were hoping this survey would be able to look at in terms of their attitudes towards science. So yay again. For those that like stats, here's the statistics on it. So we did do it small, but it's there. And that's a big deal because they come in, as you can imagine, with already fairly positive attitudes. Well, we're actually able to help bump that up. And I guess we can say at the very least, they didn't decline. So this program provides students a real. We have explicit roles for the advisor and the teacher with research. And it gives them an opportunity to collaborate with their analysis showed that the survey that we modified is valid and reliable, which is nice, which means it could possibly be used for other groups outside of students who participate in our program. And we were able to get statistically significant practical model for student-led authentic research that will also help boost their attitudes towards science. It's an opportunity that doesn't really exist in a lot of places. But research literature and national education reform, so maybe you're not quite working with graduate students yet, or maybe you're a graduate student, which we've had a number. We had a paper submitted to Acta Astronautica on this topic. So just real quick, I want to thank Survey and NLSI, all education efforts, our advisors and judges, who some of them are here today, and of course this would never be the success it was without kids like those 8 back there, or young people. Thank you.
I have to say, for me personally, this is one of the things I'm most... I'll share time for 1 or 2 questions. Tim?
Any statistics or even anecdotal stories or evidence about what the students who go through this
of them are planning to go into the sciences already. I know from anecdotal, some of them have done that. They have gone on and said that their students told them that because of it, they're going to go on and do it. But it's very hard to track people post-grad.
Was that this was kind of the close of ExMASS for the time being. Can you give an update on what the future of the program might look like?
Okay, so what might want activities and update those and get those in a little bit better shape.
Oh, okay. Apparently the battery's dead in that one. Okay, and very strongly about for all of us is that if we care enough about students through the rest of their early career, so what and you may think, oh, what you've decided to do, whether it's to stay in science or not, you're probably going to carry with you some benefits of this program. Let them know. And for the organizer of a contact listing for them, and maybe it's an email, whatever they feel comfortable with, maybe it's being on Facebook, I don't know. But some way that you can.
I'd like to comment on that briefly. There was a student who worked for me a few years back, an undergrad student who did keep in touch and is one of our survey PIs, and so that's just to underscore what Yvonne says. It's really nice to keep track and find out what you guys are doing. So now we have our two introductions.